Okay, so a very brief review of your properties of exponents you can see here in this little chart. This is something, if you don't remember these, you might want to review them. I don't want to spend too much time on it. We got the product rule, the quotient rule. It's kind of like a shortcut rule for doing some exponential stuff. Okay, so these are all going to be important for us when we do log properties. So let's go ahead and I might have to call this back up, but let's go ahead and take a look at these. Okay, so the first one's a product rule. So you have a product, the log base b of a product. Okay, so similarly to our exponential rule we end up adding, we got an addition here. So think about this, you're not really distributing, it's just the product of these two becomes the sum of two logs. Okay, for example, the log base 2 of 8 times 4 is the log base 2 of 8 plus the log base 2 of 4. Okay, there's one for division. The log base b of a quotient translates to two separate logarithms, and you're going to the difference of two separate logarithms. All right, so here's an example. You could do this two ways. The log base 5, 25 over 5 is 5, right? So the log base 5 of 5 is 1. 5 to the 1 is 5. So we know this should be 1. Here's another way to look at it. Use your property, log base 5 of the numerator minus, because it's division problem, the log base 5 of 5 is equal to, log base 5 of 25 is 2, because 5 squared is 25. And then the log base 5 of 5 is 1, because 5 to the first is 5. Okay. This property is very useful. I'm not sure what this is. This is a typo. Sorry about that. This property is very useful. Okay, it's called the power rule. We use this a lot. When you move on to calculus, you'll actually use this one a bunch too. It really simplifies my logarithmic expression. So I got the log base b of some exponential expression. Okay, and what happens here is it kind of undoes the exponential part. Well, let's look at a special case of the power rule. This might help us understand. What do you think the log base 2 of 2 to the third is? I could add this as one of my properties here. This could be like a 3. If this is 3a, this maybe is 3b. This is just 3. The log base 2 of 2 to the third, because you would ask yourself, 2 to what power gives you this thing? This thing is 2 to the third, right? So it would be 2 to the third power gives you 2 to the third power, right? The answer is 3. That's kind of weird because it's so simple. But the idea here is this is that inverse property in action. This is an exponential function with base 2. This is a log function with base 2. We haven't seen this yet. And they just cancel each other out. It's kind of like doing the cube root of x cubed. What happens there? That's just x. Right? The log base 2 of 2 to the third has to just be 3. Okay? That's a real nice property. But this one is more common because they're not always going to line up like this. This one is saying, well, if this base is b and this base is not b, what happens? Well, this simplification kind of happens. It brings down your exponent and multiply. These little periods are multiply. They should be like up here. Like a dot means multiply times. So in other words, this kind of brings down this exponent. It's a real nice property for us. All right, so it's the inverse property, but not 100% you can think of it. This is 100% inverse property, completely undoes the other. This one kind of undoes it, okay? So that is the exponent comes down and you're left with the exponent as a constant multiple times the logarithm without the exponent. Okay, here's an example. How can I deal with the log base 3 of 9 squared? Well, I just take the 2 and bring it down. Take the 2, bring it down 2 times the log base 3 of 9. In this case, you could simplify log base 3 of 9. Okay, so we might consider 3b then if I'm using base b, another property. The log base b of b to the, well, let's use n for the exponent, equals what? The log base b of b to the n would just be n. Okay, but we could also use this property for that one as well. There's also the change of base. All right, change of base. I can explain this one when we solve log equations. I'll talk about this one later. For right now, let's just be able to use it, and then I'll have an explanation later. I like to explain this when we solve log equations. You'll kind of see how it's how it works when we start solving equations here shortly. Okay, so the log base b of m, if I want to, I can change the base to any base I want. We're using k here. And I can say the log base k of what you're taking the log of in the original expression goes on top, and the log base k of the other one of this number goes in the bottom. All right, so what does that look like in this case? Well, let's say I have a calculator, and the calculator is the two log buttons. If you look at your calculator, are going to be the ln button and the log button. Those two special logs I talked about. Now, if you have a fancy calculator, you'd probably be able to type in what base you want. All right, but if you don't, if you have like a scientific calculator, it's typically just two log buttons. And what you can do is to change your base. If you want to evaluate the decimal value, log base 2 of 8, you can change the base. So you'd pick one of these, right? You pick one. So let's say I pick the natural log as my base. So it's the natural log of this number on top and the natural log of this number on bottom. And then you can divide them. Okay, and you know it should be 3. You're just kind of, this is an example to see if it's true, because you know the log base 2 of 8 is 3, right? Because 2 to the third is 8. But you can try it on your calculator to see what you get. Which, by the way, this has to work with this other log too. Any base is what I'm saying for the change of base. So you can check this one, plug this into your calculator, common log of 8 over the common log of 2, and you should also get something really close to 3. Okay. Couple more properties. See if this one makes sense right here. Remember, base b is the same rule, the same restrictions apply to b as for exponential. It has to be greater than 0 and not equal to 1. All right, that's always the case for my base of my log, just like it's always the case for the base of my exponential. So what does this have to be? Well, this is a special input for the log. B to what power gives you 1? Got to be 0. Right? Got to be 0. That's the only number that makes this true. So in other words, it's kind of a special case for logarithms, but you're doing it the same way. B to what power gives you 1? You might remember that's one of our exponential properties. There it is. The 0 exponent. A to the 0 is 1. Okay. What else? Hopefully this one makes sense. Oh, wait. That's the same one. Logarithm of the base. Oh, this is a typo. I copy and pasted that one, so I'm going to fix this. Rule 6, log base b of b. What do you think that is? Log base b of b. That is, what if the bases line up? Well, you would ask yourself, b to what power gives you b? Got to be 1. Okay. And then I had my, oh, here it is. This is what I called 3b, so we can call it rule 7 if you want, but it's very closely related to this power rule. And this one you won't see as common, or you won't see it as frequently. And we can call it the inverse property, since you can do it both ways. That is, what's the log base b of an exponential expression? Well, the bases cancel out, you're just left with x. And that works the other way as well. This is kind of a weird looking expression, but if I have an exponential expression where the exponent is actually a logarithm and the bases are the same, then they would cancel out as well. That's your inverse property. Okay? All right. Let's use some of these properties. Now we get to practice with them. So the ones we'll use a lot is, as you can see here, I got a product, I got a quotient, and I got some exponents. So which ones am I going to be using? I'm going to be heavily using 1, 2, and 3. We're going to really use these a lot. Let's take a look at what that looks like. All right, so for my example 7a, base is 3. And what do I have here? Okay, so this square root looks kind of funny to me. So I don't have any rules for square roots, right? I don't have any rules for square roots. So I might go back to my exponent rule and say, what's a square root? Remember this one? Sorry, it's a little hard to see. Right here, you see this root? A root is a fractional exponent. Oh, that's going to come in handy, right? A root is a fractional exponent. So let me write that one down. A to the m over n is equal to, the denominator is the root, and the numerator is the power. Okay? So I can apply that here. This is a square root. So that's the first thing I'm going to do is deal with this root. You'll see a bunch of these. So this is xy to the 1/2 power. Okay. How am I going to simplify that? So I should be thinking property 3, where the exponent comes down. However, the 3 isn't raised to that 1/2 power. Okay, so the first thing I got to do is use my product property so I can isolate this guy with the power. So watch what that looks like. The log base 3 of a product is the log base 3 of the first piece of the product plus the log base 3 of the other piece of the product, and that's xy to the 1/2. Okay? Now, what do we do next? Well, this one we know that's 1, so we can take care of that. Log base 3 of 3 is 1. This one is the property I'm saying is really useful. When you're taking the log, any base, of an exponential expression, I can bring the exponent down. So I get to bring that 1/2 down, and then have the log base 3 of xy. Okay, but I'm not done yet because the directions are expand. So I can keep going here. I have 1 plus 1/2, and now I have the log base 3 of a product. So that's going to be the log base 3 of x plus the log base 3 of y. And then I think I'm done. This would be an acceptable answer. I like that answer. Or I can distribute the 1/2 if I wanted to, but I think we've achieved our goal. Directions are to expand. Okay? How about the natural log one? Same idea. These are going to be kind of similar, I think. So I'm going to say, all right, the natural log of a product. It'll run through a product of 3 items, or 3 inputs. So that's the natural log of x squared plus the natural log of y. Ooh, where's that 3? Let's call it it's kind of hard to see. Let's call that 3 a power, not a root. And then that's another square root plus the natural log of z to the 1/2. And then I've kind of done the goal of expansion, but I could make the directions a little bit better. Let's say no exponents allowed. Expand with no exponents. All right, so that means I use my power rule to bring all these guys down. And my final answer looks like this. 2 times the natural log of x plus 3 times the natural log of y plus 1/2 times the natural log of z. Okay, one more for this video. I got a quotient here, so the first thing I do is recognize the quotient. I do common log, remember that's base 10 of 4x, minus the common log of y squared. And then I can apply my product rule, log 4 plus the log x, minus I can apply my power rule, 2 times the log y. And those are all common logs, or log base 10.